Good afternoon, sir.
Yeah, good afternoon. Good afternoon. At last minute, actually, we got problem with the Zoom network. So at last minute, we have scheduled. Please inform your friends also to join fast. Today we are going to take the problems. Okay. So please inform.
Okay, sir.
To join first. Nobody has to miss those.
Okay, sir.
No, no. On the screen, which one you are seeing? Tell me. Blue color winding is there? No.
Yes, sir.
Yes, yes. This is mutual inductance. How many coils we are having?
Mutual.
Yes, we are having how many
Two.
coils?
Mutual
Two.
induction, two.
Yes, self-inductance.
Two.
Okay. Self-inductance, how many coils we are having? Only one. Okay, self-inductance, magnetic energy is not shared with another coil. But what is mutual inductance? If we are having one coil, current flows through how many coils? One coil or two coils? Only one coil. But magnetic energy is shared between coil A and coil B. That is inductor A and inductor B. I hope it is clear now. So mutual induction means if the magnetic energy is shared between two coils, it is called the mutual induction. If the magnetic energy is not shared between the coils, it is called self-induction. Okay. Now we go with this one. So what are the material as I release, you prepare that one. So today's class, with the knowledge of self-induction and mutual induction, we take the dot convention. Okay. So all of you be ready with paper or book. Okay. As you are taking the new problems. Okay. But first you listen.
Please.
But you first you listen this one. Don't never.
కోడి ఇస్తలేదు మనిషి ఏమో ఇంత
Mute లో పెట్టండి ఎవరో. 57. Please mute yourself. Dot convention. What this dot convention is used? Dot convention explains whether mutual inductance is positive value or negative value. All students remember, always self-inductance value will be positive only. But mutual inductance or induction value will be negative or positive. So you are having one word, sir, why we are using the word induction? So now I'll confirm that one once again. Give me 1 minute. Why we are using the word induction? So when we have to use the word induction, now you see, if magnetic energy is shared between the coils, then we have to use the word induction. Understood? If I am using battery between two coils, then I have to use the word conduction. So wherever battery is present, the word is nothing but conduction, energy transfer. Wherever magnetic energy is present, the word is nothing but induction. So magnetic energy is present between two coils means it is mutual induction. Okay. Now on the screen, what you are able to see now? Anyone?
Dot convention.
Dot convention.
So they will not ask you define dot convention, but you have to remember dot convention explains when mutual inductance is positive or when it is negative. Okay, mutual inductance. Always self-inductance values are positive only. Okay. So now you have to remember this table. For you people, I brought it this one. Same thing you can write. What is this table? Entering positive, leaving positive, entering leaving negative, leaving entering negative. One student raise your hand and read out.
Entering is equals to positive. Leaving is equals to positive. Leaving is equals to negative. Entering is equals to negative.
Negative. Very good, very good. So you have to remember this code, okay, this simple logic. Now, what is entering and what is leaving? So the real answer is note point we have given, okay. Current is entering the dot marked point. That means in the circuit, now I am going to show you dots will be mentioned. That's why the name is dot convention. Wherever dot you are seeing, you must assume that current is entering the dot or current is leaving the dot. That is the meaning here, okay. So now dot convention says that whenever current enters, it is positive. Mutual inductance is positive. Sir, what is this? Okay, we are remembering. Now let us take the circuit now. All of you, this is new topic for you. Now first see the circuit one or the diagram one, series connection. They will give you explain series connection. Okay, series connection of all of you see coupled coils. Coupled coils means what? If two inductors or two coils are sharing the same magnetic energy, then they are coupled coils. Coupled means connected. How they are connected? Magnetically connected. Okay, all of you, first circuit, observe carefully now. Okay, now dots are mentioned here, year one dot and year one dot. So how many inductors? Anyone tell me? First circuit, one student. Two inductors. Okay, good. Two inductors, L1 and L2. Okay, two inductors are there.
L2.
And two inductors are, see, now I am not drawing the circuit. Initially, I have drawn circuit and bulb, everything. You can draw the symbol also. Yes. Once again, 57, you are creating disturbance. Now, two inductors we are having. So instead of drawing the circuit, we can draw like this also. Mutual induction is present between L1 and L2, two coils. Now all of you see here, current is entering now here. Dot is present before the inductor. If dot is present before the inductor, current is entering. If dot is present after the inductor, at the end of the inductor, current is entering. Now you see all of you, current I for L1 is entering. Okay, okay. And now same current is flowing. It has passed the L1. Now anyone tell me, what is the condition of current for L2? It is leaving or entering? This current will come here. That is what we have to imagine. Think and tell me.
Entering.
Entering, very good. So entering. That means if the dot is present after the inductor, it is leaving. Okay. So if current enters the dot marked terminal or end point, okay, entering, then the mutual induction or mutual inductance is positive. Okay. So always self-inductance is positive. So what is the mathematical formula? Total inductance L1. How many inductors are there? L1 plus L2. Always these are positive. Now we have to say whether this is plus or minus. Plus or minus, tell me. Current I is entering for L1. Okay. And for L2 it is entering or leaving? For L2 it is entering. So entering, what is our formula? Entering is positive. Therefore, we write here L1 plus L2 plus, you can say, sir, why you are writing, why we are not writing M? Why we are writing 2 into M? So this mutual induction is present for L1 and L2. So 2 times you have to write 2 into M. Is it clear now? This one. Okay. Now come to this one. This particular second one. Who will tell? Raise your hand and tell me the value. Current. Yes, 51. Come on. 2 participants are there. Second participant. Let us give the chance to others also. One more student who has raised their hand. Please answer me.
Entering the current.
Entering the okay, current. Here what it is there? Entering or leaving?
Leaving.
Very good, very good. See, dot is placed after the inductor. So current, it is series connection. Same current will come here and it will flow through L2, but dot is present at the end point. They will give in the question where the dot is present. So current entering and leaving. Entering, leaving is what? Minus or plus? Entering leaving
Negative.
is negative.
Minus.
Therefore, minus you are going to write. So what is the practical meaning of this minus and plus? Means here magnetic energy subtracts. Here magnetic energy adds. That's why you can read mutually coupled coils in series aiding, series opposing. Okay. Entering leaving means minus means magnetic energy value decreases or subtracts. So what is expression here? Two magnetic fields. Therefore 2 into M we write. L1 plus L2. Now you tell me all of you what is this symbol? Minus 2M. L1
Minus
plus
2m.
L2 minus 2M. Okay.
Minus
2m.
2m.
2M. So this is what directly we can write for you people. Now one more diagram I'll show you. Now be ready with the paper and pen. Okay. Now tell me this one. No need of expressions for you. All of you. Circuit you are seeing now. What is expression?
Entering, sir.
Entering and entering positive.
Entering and entering positive.
Entering positive. What is the equation? I want the equation.
Positive.
L1 plus L2
L2
plus
is equals to M.
not equal to L1 plus L2. Total inductance L is equal to L1 plus L2 plus 2 into M. 2 into
2
M.
into M.
2 into M. Because 2 times it is exchanging here. Okay. Mutual inductance is present for primary winding and secondary winding. These are primary and secondary only. Okay. Now, so where we use this concept? So in the transformers, depending upon the current, we get the magnetic field increasing or decreasing. Now tell me the next one. So for you, these equations are not there. So as in the mathematics, differentiation is not started, we are not supposed to do. Now tell me the equation now. Total inductance.
Entering and leaving, sir. Entering and leaving.
So what is the expression?
Entering and
L1 plus
leaving.
L2 minus 2M. Yes or no?
Minus
L1
2M.
plus minus 2M. Now come to the problem. They'll give you the problems like this. Question. Read carefully. Now, two inductors. Okay. 10 millihenries. Inductor unit is Henry. The scientist who has brought his name is Henry. Okay. Milli means what? Very small. 10 power minus 3. Micro means, anyone tell me? Micro means 10 power minus 6. Nano means 10 power minus 9. Very small. Our cell phones are, nowadays we are using the smartphones. They are having micro components. Very small components. Nano means still research is going on. Nobody has invented. Okay. So we say two inductors. Okay. 10 millihenries. That is 10 into 10 power minus 3. What is the value? 10 into 10 power minus 3. No need to write all these things 10 power minus 3. For your knowledge, I am telling you. Okay. Two inductors 10 millihenries respectively are connected together. All of you see, series opposing means what is the formula? Anyone tell me? Magnetic fields opposing. Opposing means L1 plus L2 minus 2M. Series aiding or adding means what? Magnetic fields are entering. Entering, leaving, another name is series opposing. Entering, another
Series
name
opposing.
is entering, another name is series adding or aiding. Okay. Now, two inductors, 10 millihenries, okay, respectively are connected in series combination so that their magnetic fields or energies are what they have given this word. Anyone read out? AID each other. That is adding.
AID each other.
Yes, adding or aiding each other. Okay. Cumulating means total coupling. So now you tell me they are aiding means what? Entering. What is the formula for entering? It is positive.
L1 plus L2
L1
plus
plus L2
2M.
plus L2M.
2M.
2M.
So why you are writing L1 plus L2? Here he has mentioned two inductors only. If three inductors, L1 plus L2 plus L3, not 2M directly. That is different. Okay. So you have to write the formula. What is L1? 10 millihenries. L2 is 10. And they have given the mutual inductance is given as how many henries? 5 millihenries. Calculate the total inductance. So 2 into 5 millihenries. What is the answer here? 30. Okay, all of you. So the same problem I'm saying here, instead of aiding each other, I'm writing opposing. What is the formula now? Magnetic fields are opposing.
L1 plus
Plus
L1
L1
plus L2
plus
minus
minus
L2
2M.
L1 plus L2 minus 2M. Okay, so
2M.
same problem. The material I will share you. Okay, you can take that one. The same thing they have written. Now this is what we are coming to the real one. All of you, this circuit you see and tell me it is visible or not.
Visible, sir.
Visible,
It's
no, all of
visible
you?
only, sir.
Circuit is visible. All of you? Okay, later on you
Yes,
can
sir.
draw. But watch this circuit carefully. You can, if you want, you can take the screenshot also, no problem. But anyhow, I'm going to share. Now you see this circuit. Okay, assume water is flowing from point A to tell whether they are series or parallel. Water is flowing here. Water is also flowing here, and same water is flowing. Is water is dividing here anywhere? No. Therefore, this is
No.
No, sir.
therefore we say this is
Series.
nothing but series only. Now we have to say whether it is series aiding or series opposing. Okay, we'll see that one. Okay, now all of you check here. Ready now, all of you? Now, so what is the answer? What we have to write means, see, down I am writing. You must write along with me. Total inductance L is equal to, okay, total inductance LT, L capital T, or L you can write. Total inductance L is equal to, now you see, how many self-inductances are there? How many self-inductance?
4.
Self-inductances
Three.
means, all of you see.
3.
See, all of you, very good. Self-inductance
3.
means they are represented at the inductor. So what is the self-inductance? 1, 2 Henries. Next one, 4 Henries. Next one, 3 Henries. Yes or no?
3.
Self-inductance. So we write here first all the self-inductances. Let us say what is the first self-inductance? 2. 2 plus, always self-inductance is positive.
2M.
2 plus 4 plus, next 3. Is it okay, all of you? Any problem? No need to write formula. Forget about L1 plus L2 plus 2M or minus 2M. Because we are having 3 coils, 3 inductors. Okay, 3 inductors means 3 self-inductors. 2 plus 4 plus 3. Is it okay, all of you? Okay. In
Yes,
between
sir.
the inductors, we are having mutual inductance. Always mutual inductance M will be present between the inductors. In problems, they will not give the M value, they give the number. Okay. Now you see, all of you, carefully you have to see. Between 1 and 2 coils, or between L1 and L2, we are having the mutual inductance 4, which is represented by dot. Okay. But between L2 and L3, the mutual inductance is represented by dot or delta shape. See carefully.
Delta shape.
Delta shape.
Delta.
Okay, that is, there are 2 mutual inductances in this circuit. One mutual inductance is present between first inductor and second inductor. Second mutual inductance is present between second inductor and third inductor. Now, are you able to see any mutual inductance between first and third? First inductor and third inductor? No, they are not given. 0.
No.
Okay, 0. Now you see, all of you, start now. Okay. First, for any problem, we have to write how many self-inductors are there. Okay, we have written 2. Always self-inductors are positive. 2 plus 4 plus 3. Okay, right. Examiner will see answer only for this one. Now to write whether plus 4 or minus 4, we have to use the dot convention. What is the use of dot convention, anyone? Dot convention explains whether mutual inductance is positive value or negative value. Okay, right. Now start from here. Now we are targeting the mutual inductance, whether it is plus 4 or minus 4. Anyone guess? Okay, first I'll explain. Current, assume current is starting from A. Current is flowing, and now current is entering the dot or leaving the dot here, all of you. See, a dot is mentioned. Current is entering the dot, and now that current, yes, current is entering the dot. Now that current, yes, please mute yourself. Current, and that current is flowing. It is coming to the second inductor. Now this current is entering or leaving where this dot is present. After the inductor, how to say, see, don't imagine that like this, right hand side, left hand side. Start from the point A and current is flowing here. Okay, first inductor it is entering and that current is coming down through this wire. And for the second inductor, what is explanation? You should not see the delta now because we are writing for first and second inductor. First and second inductor, it is only dot. So current has started from point A, current is approaching the inductor 1, it is entering, and the same current is flowing, it is moving towards inductor 2. Now tell me, it is entering or leaving now?
Leaving.
Leaving, very good. Because dot is placed after the inductor. How to decide after or before? depending upon the current flow. Current has started from point A, it has entered here, and then current is here, it is flowing, and according to this dot, it is leaving. So entering, leaving is what? Anyone tell me? Negative or positive?
Negative.
Entering, leaving, negative. Entering, positive. Leaving, positive. Entering, leaving, negative. Leaving, entering, negative. Okay. Now, right. So now I have written minus. Okay. Now what we say, mutual inductance is present 2 times for every inductor. Yes or no? In formula we are having 2 into M. But here what is the mutual inductance value? 4. So minus 2 into 4. Okay. Answer is 7. You will get 7 answer. I am giving the hint. Now come on. This one is understood, all of you? 2 into 4 we have written. Okay. Now come to the next one. Next one. Who will tell? Next mutual inductance. Again start from the current. Start from the point A. Okay. Current is entering. This is finished. This one is finished. Now we are writing the mutual inductance between second inductor and third inductor. So current is leaving or entering? Tell me now for delta shape. Understanding or not? First we have written for dot. Now we have to write for the delta.
Entering.
Between second and third. Now
Entering.
you see all of current started from A, and see if the current is flowing like this. See, you have mentioned entering answer is wrong. Why I am saying is, don't think that it is placed here. Current comes like this. Okay, in this way. No. Current flows through the wire. Current started here. It flows through the inductor 1, and then it comes to the inductor 2. Inductor 2, where is the delta? Here before it is there delta? No. Current will flow through the inductor. Now the delta is there. So current, it is leaving now.
Yes, sir.
It is
Leaving.
Now you tell me for the last one. Those who have just now mentioned. Current is flowing through the wire and it is entering or leaving. Where is the delta?
Entering.
Leaving, sir.
Entering,
Don't get
sir.
confused here.
Leaving, sir.
Yes.
Entering, sir. Entering.
Okay.
Leaving.
Be cool. All of you be cool. Once again, I repeat, because it is entirely new thing. So I'm just erasing the answer here. So this is the circuit. All of you get ready. How many inductors are there? All students, 3 inductors.
Three.
So
Three
first all
inductors.
2
Three.
plus 2 is present. 4 plus next one is what? 3. Okay, that is done. Now, which inductor will write? Which mutual inductance will write first? Anything you can write. Tell me, shall we write this one? 3H mutual inductance first? Okay, we'll write this one. Okay, write all of you. Okay. Mutual inductance between second coil and third coil. We'll write this one first. Then we'll write this one. Now start all of you. What is the diagram he has given? He has given between 2 and 3. Which symbol he has given? Delta he has given. Yes or no?
Delta.
Delta. So now concentrate the delta. Now current, where it will start? It will come directly here? No. Current start from the point A. So current is flowing here. Now inductor L1 we are using? No, because we are writing the equation for between mutual inductance between L2 and L3. Yes, 48. Please ask the question. Any question is there? Any answer? Tell me, don't hesitate if it is there. Okay. So current started from point A and then it flows through the L1. L1 now I am not writing first. So current flows through the, now you tell me, for inductor L2, the current is leaving the delta or entering the delta? Anyone?
Leaving, sir.
Leaving.
Current is leaving the
Leaving.
delta, and now okay, now current is coming down here for L3. For L3, current is entering or leaving?
Entering.
Think and see where the delta is present.
Entering.
Delta is present here.
Leaving, sir.
Okay, current is
Leaving, sir.
leaving.
Leaving.
So we
Leaving.
say
Leaving.
Leaving.
Leaving is positive or negative? Leaving is positive or
Positive.
negative? It is positive.
Positive,
sir.
Plus, and
Positive.
mutual inductance, no, 2 into what is the mutual inductance value? 3. Okay.
2 into 3.
3. Now we'll write the top one. Any order we can write. Now all students listen carefully. So what is the mutual inductance? 4. It is present between L1 and L2. Is 4 is present, is having any relation with L3? 4 Henrys? Mutual inductance? No. The dots are shown for L1 and L2. Now you tell me. Current has started from A. It is Where is the dot? Tell me now.
Don't.
Entering, sir.
Current. Current is, yes,
Entering.
dot is present
Enter.
before the inductor. Because current is coming here. So it is entering. And what about here? Dot, where is the dot here? Current is coming like this now.
After the inductor.
Sir,
After
leaving.
the inductor.
After the inductor. Very
Leaving.
good. So it is leaving. Entering, leaving is what? Minus. Okay.
Minus.
Entering, leaving is minus. And 2 times 2 into what is the mutual inductance value? 4. Now tell me the answer. How much you will
4.
get? Total answer?
7. Just one sir.
You are getting this 7.
4, 5, 6, 7. 7.
Okay. 7.
7 sir.
Okay. See all of you. I'll repeat once again. No need to worry. But for practice purpose, let us move to the next circuit. Be ready. Be ready. Don't confuse all of you. Okay. Second circuit I'm showing here. Okay. It is on the screen now. Only circuit. Write the answer you have write. Total inductance cell. All students. This is 10. This last one is 10. Okay. Last one is 10. Be cool. First listen my explanation. How many inductors are present? 1, 2, 3. Yes or no, all of you? How many inductors? 3.
Yes, sir.
And inductors values, how much they have given? 8, 10,
8,
6.
10.
So first we write 8 plus 10 plus 6. Is it okay? All the students. Okay. 3 inductors and 3 values are there. 8 plus 10 plus 6. Anyone student not understanding this one, you tell me now. Raise your hand and be perfect, because these are tough. Very first time you are listening. For the given circuit, please mute yourself. For the given circuit, 3 inductors are present. Okay, 3 inductors. So 3 inductors, 8, 10, 6. Okay, we have written. Now, mutual inductance. Now let us see between first and second coil. Anything you can see. Ready now? First and second coil, there is mutual inductance. What is the value? 4. Okay. What is the value? 4. Okay. Now you start this one. Start current. Assume that current is starting from point A. So current flows here. Now you tell me. The dot is after the inductor or before the inductor?
After the inductor, sir.
So how you are saying it is after the inductor? Because current is coming from A.
Current is flowing from A.
From A. If current is coming opposite to A, it is before the inductor. But we are not taking that one. We are assuming that current has started from A and current is flowing from A. So current is flowing from A, but the dot is present after the inductor. So current is leaving the inductor. Okay. So it is leaving. And the same current it is flowing. Now you tell me it is entering or leaving?
Entering, sir.
All students, it is 100%
Entering.
So
Entering. Before the inductor.
Very good. So leaving and entering. So leaving, entering is plus or minus? Leaving, entering is minus. Okay. Minus 2 times the 2 into, because mutual inductance will present for 2 times. Both inductors. What is the mutual inductance value? 4. 2 into 4. Okay. Now anyone tell me this one. Now we have tried for L2 and L3. What is the mutual inductance they have given? 5. Is it right? 5. All of you? 5. Now again, don't get confused here. Again, start from the A. Current is flowing through this L1. L1 we have already written. No need to use. This dot is finished now. Now current flows through this wire. It is coming to second inductor. And now mutual inductance is present between second and third. One more mutual inductance. So now you tell me. The current is entering the dot, okay, and it is entering, and then it is coming down. Now for this third inductor, tell me, current is entering or leaving?
Entering, sir.
Current is 100% entering. Current is 100% entering. So entering is what? Positive or negative? Yes, tell me.
Positive.
Positive. Entering is positive. 2 into answer check, we have to get 26. 2 into 5. 26 we have to get answer. Check anyone. Add and subtract.
Yes, sir, answer is 26.
26. H we have to write. Henry's no answer. That's all. Answer is 26. So all of you try this one at home. Okay, this one values are not. Equation we have to write. You can take screenshot. See, I am telling the answer. L1 plus L2 plus L3. Okay, entering here. Current start from here. Entering 2 into MA. Okay, and next between 1 and 3. I'll explain later on tomorrow because you'll get confused. But you take this one screenshot and work with the answer. This problem, you take the photo. Last 1 minute is the time. Screenshot. Try for the answer. This one.
Okay,
Current
sir.
start from the A only. Always current start from the A. So how many inductors again? 3.
3.
4
3.
plus 2 plus 6. Okay, and between first inductor and second inductor, what is the relation? Tell me fast, anyone. Entering, and here it is
Leaving.
So
Leaving.
which is present mutual inductance? 1 or 4?
4.
4 is present. Very good. So 4 plus 2 plus 6.